In this question, we're going to use the Venn diagram shown here to answer a series of questions, the number of and the probability, and also display it in a two-way table. The important things that we need to remember is that if we think about set A and set B and how many things are in both, we need to realize or remember that there are 5 plus 2 things in set A. So there's actually 7. It just so happens that 2 of them are also in B. But if we're thinking about A in total, there are 7 things in there. If we're thinking about B, it would be 6 plus 2. So there are 8 events that happen in B. And that's going to be really important for us to remember. The first question here tells us to display the information in a two-way table. Now remembering how we display things in a two-way table is that we need to construct it, and we put A and the complement of A in there. We put B and the complement of B in there. Obviously our totals are going to be in the most outside ones and the bottom ones. Now, if we're thinking about A and B, so this is A and B, well, what is in A and B? Well, we can see that there are 2 in A and B. If we think about it differently with A but not B, what is in A but not in B? Well, there are 5 things that are in A that are not in B. And that means there are 7 things in A. 7 things in A. We know there is that. If we think about B, well, what is in B that is not in A? Things that are in B that are not in A is 6. 2 plus 6 is 8. And obviously here, that is correct there. The last thing that we need to remember is that there are 3 things that are not in A and not in B. So we put a 3 there. If we were to do our totals, obviously all of this adds up to 16. So there are 16 events totaled in this two-way table, and we've displayed that in the information quite clearly. From here, we can use this information provided to answer a series of questions that relate to the Venn diagram and also the two-way table. We might quickly go through them now. First one talks about the number of people in A intersection B. Well, the things that are in both A and B is 2. And we can see that there. The second one, when we talk about not in A but in B, so not in A but it's in B, well, that would be 6. So not in A but it is in B. So not A but yes to B, 6. This one is the opposite. It is in A but not in B. In A but not in B, that will be 5. Next one talks about, well, it's not in A and it's not in B. That will be 3. Next one talks about the number that is in A. So A, everything that's in A would be this number here, 7. Going through to the next one, everything that is not in B. So if we go B, not in B. Going on to the next one, the number of people in A union B. So everything that is in A and B. And we know that that is quite clearly going to be 13 because we're going to add up the 2, the 6 and the 5 because that's in A and B. So we add up those ones and that's going to be 13. This number represents how many in total, and that number is 16. Final part to this question is working out some probabilities. The probability of one being in the intersection, there was 2 in the intersection over 16, so that equals 1 over 8. The next one is the probability of something being in not A. There was 9 in not A, so 9 over 16. And the last one, probability of this, we go to A but not B, and it is 5 over 16.